Well, we're running a little late, folks. Good night. So now the part you've all been waiting for, the better parts. So this is Antoine de Saint-Exupéry, forgive my French, a brilliant writer, aviator. He's best remembered for having written The Little Prince, amazing book. I don't think it's really a children's book. He wrote other books about aviation, and in one of them he wrote this amazing thing. He said, "It seems that perfection is obtained not when there is nothing more to add, but when there is nothing more to subtract." He was talking about the design of airplanes, but this statement has been applied to design, engineering, architecture, anything that combines creativity and discipline. Just a really brilliant statement. And I think it especially applies to programming because programming has a very unique relationship with perfection. Computer programs have to be perfect or they don't work correctly. Nothing else that humans make need to be as perfect as programs do. And I think it applies especially to the design of programming languages. And it's very compatible with the idea of good parts, that there can be good parts in languages and bad parts in languages, and we get closer to perfection when we use only the good parts. The principle of the good parts is that if a feature is sometimes useful and sometimes dangerous, and if there is a better option, then always use the better option. I think this seems obvious, but this is a really controversial idea. And there are a lot of programmers who say, I don't want to use the better option. I want to use the dangerous option. And I think this is because of a misunderstanding about fundamentally what we're supposed to do. We are not paid to use every feature of the language. There is never a manager at the end of the project who's got a clipboard and he's looking at the code and saying, did you use a double equal? Did you use a with statement? No, what they're looking for, we're paid to write programs that work well and are free of error. Free of error. When did that become part of the deal? It's always been part of the deal. It's always been the first requirement, but we attain it so rarely, it's easy to forget that that's the most important thing that programs have to do. So I recommend that everybody learn as many languages as they can, programming languages, because a good language should teach you. Every language introduces some new ideas, and those ideas can make you a better programmer. The language I'm most associated with is JavaScript, because I discovered that there are good parts in JavaScript, which was surprising. And when I started working with this language, I made every mistake that you can make with JavaScript. Starting with the first one, the worst one, I decided not to learn the language before I started writing in it. That's a mistake a lot of people like to make with this language, but it's not a good thing. And until you learn the language, it can't begin to teach you. But eventually I did learn the language and discovered that in addition to all of its obvious faults, there was wonderful brilliance in the language. And I started thinking about how to better use that brilliance. One of the things I did was I wrote a program called JSLint, which understands how the good parts work. In fact, JSLint is much smarter about JavaScript than I am, and has taught me also a lot about how to try to move toward perfection in programming. So I wrote a book about my experience in learning about the goodness in JavaScript. I wrote JavaScript, The Good Parts. This came out 7 years ago, I think, and it is still a bestseller in its category, which is extremely unusual in a software book. Most software books become obsolete very quickly, but this book is still relevant. But the idea of good parts is still surprisingly controversial. And there are a number of arguments against using good parts. So I'd like to look at some of these arguments. The first is, it's just a matter of opinion. You say it's good, I say it's bad. You say it's bad, I say it's good. It's just opinion, it doesn't matter. That turns out not to be true. I'm the maintainer of JSLint, and so I get bug reports from people from all over the world where they describe to me problems that they had where they spent weeks diagnosing some weird thing that JavaScript allowed them to do. And they propose a modification to JSLint which would have detected such a thing. And so the existence of those sorts of faults of the language is not opinion, it's fact. And in fact, Good practices can help you to avoid those. I'm very happy to report that I've been getting fewer and fewer of those sorts of reports. I'm hoping that we have found most of those terrible problems. And if you're using JSLint, you'll never find them. Every feature is an essential tool. I need every tool that's available in order to do my work. That's not true. It turns out that you can write better programs by using only the good parts. So if you can write something better without using a tool, then that tool is not essential. I have a right to use every feature. Well, we've now changed the conversation. We're not talking about what's the best way to write programs now. We're now talking about I have a right to write bad programs. And I don't care. You know, that's not an interesting conversation. You may have the right to write crap, but you have a responsibility to do good work. I need the freedom to express myself. I am a poet, and the way I express my poetry is by leaving out the semicolons. I need to reduce my keystrokes. This is a really common misconception. We think we spend most of our time typing, and we don't. We spend most of our time looking at the screen saying, my God, what have I done? Why isn't this working? If I could figure out a way to increase your keystrokes by a factor of 10 and cut your error rate in half, that would be a huge win. I don't know how to do that, but if that were an option, that's definitely what we should do. You should not encourage bug creation by trying to avoid keystrokes. It is an insult to suggest I would ever make a mistake with this feature. Yeah. And there is a good reason those features were added to the language. I can tell you for a fact that that is not true. Bad features get added to languages all the time. JavaScript was designed by a very brilliant man named Brendan Eich, and he describes a feature called a foot gun. A foot gun is a feature in a language that you use to shoot yourself in the foot. And he put a lot of those into JavaScript, and he regrets having done that, but there are a lot of them. So just because there's a foot gun available doesn't mean that you want to be, I always miss, almost always miss. It's great, it's all right. So the purpose of a programming language is to aid programmers in producing error-free programs. That's what the whole thing is about. It used to be thought that it wasn't possible to write good programs in JavaScript because it's such a silly language. Therefore, there's no reason to even try. But we now know better. We now know that it is not only possible to write good programs in JavaScript, it is necessary. Because it is so easy to go off the rails with JavaScript, this language requires more discipline than any other language. There are two ways that I see people get into trouble. One is the fantasy of infallibility. I see this especially in younger programmers who think, I have such awesome skills, I can just write crap and it's going to work. And then older guys I see sometimes suffer from the futility of faultlessness, that they've been doing this stuff for so long and they have never seen it go right. It's like, why even bother? So two completely different perspectives, but they both lead to the same bad practice, which is danger-driven development. And one of the examples of that in JavaScript, obviously, is semicolon insertion. JavaScript has a terrible feature in which if you leave a semicolon out, it'll put one in for you. And that was intended to make the language easier for beginners, but it doesn't work correctly, and sometimes it fails. It sometimes puts them in places where it shouldn't, and sometimes doesn't put them in places where it should. And anything which causes errors like that is something to be avoided. So if you want to make your programs look like they were written by a beginner, leave them out. But if you're professional, you will not make that mistake. So managing programming is very hard because figuring out how to schedule stuff is really hard. We don't know how long it's going to take to write a particular piece of code. We can make estimates based on experience, but those tend to be very unreliable. But even harder is figuring out how much time will it then take to make the code work right. Now that time B, should be 0, right? We should write it and it should work. But often time B is longer than time A. And I've seen cases where time B was infinite. And that happens when code is finished, but never works well enough to go to production, and so the project is canceled between the time it's finished and the time they get it to work. So what we should be trying to do is to force time B to be 0. If you do anything in time A which increases time B, then we're doing it wrong. So we should always take the time to code well. So there's a new edition of ECMAScript coming out next year. It should have come out a couple years ago, but it finally comes out next year. And it's going to provide us with some new good parts. This is going to be my most favorite new good part, proper tail calls. If the last thing a function does is return the result of calling a function, this gets optimized by the compiler, so instead of generating a call return, it's going to generate a jump. So it's going to be able to go much faster, and it'll enable new forms of programming. JavaScript finally becomes a real functional programming language. This is going to be great. We're going to get the ellipsis operator, which will allow us to deal with functions that take a variable number of arguments. So this is two versions of the curry function. The first one is written in the new notation. The second one is written the way you have to do it now. And it's just inexcusably awful. It's just bad, but the new syntax is great. So I'm really looking forward to that. We've got a new module, which mitigates the problem of JavaScript's global object. So we can now have modules which can link each other correctly. That's going to be great. It also replaces the terrible require thing that CommonJS did. Modules will be terrific. We have a new let statement, which works just like the var statement, except it will respect block scope. This doesn't allow us to do anything that we couldn't do well before. It turns out function scope is adequate for writing good programs. But a lot of people come to JavaScript from languages that have block scope, and they get confused by the lack of it. So I'm going to recommend that we all use let, because that will eliminate that confusion, because confusion creates errors. Then there's destructuring. You can't see all of that, but it's a new shorthand for pulling values out of an object. It's going to be, doesn't allow us to do anything innovative, but it is a nice convenience. Then finally, weak maps. Weak maps are a special kind of object that work the way objects always should have worked, where any value can be a key. It doesn't have to be a string. Any value can be a key, which is brilliant. It'd be nice if we could have fixed objects to have this property. We couldn't do that, so we're adding another thing. So it's clumsy having, we now have two kinds of objects, normal objects and these weak maps, which work correctly. It's the worst named feature ever put on anything in a programming language. Nobody wants to put something weak in their program, but these are brilliant. We can do things with those that we couldn't do before. There are lots and lots of other new features in ES5. We don't have enough experience with it yet to know which are going to be good and which are going to be bad. One thing that I know is going to be bad, the worst bad part added to ES6 is going to be classes. There's a new class syntax in ES6. It was the most requested new feature. It was mostly requested by Java developers and C# developers who need to use JavaScript, but they don't want to have to learn it. And so this new class thing will allow them to pretend that they're working in a different language. The reason this is a bad part is it's a trap. Because if you're using the new class syntax, you will never learn how to use the language correctly. And there are much better ways to use the language than classes. The people using classes will go to their graves never knowing how miserable they are. So I've been reconsidering some of the things that I used to think were good parts in the current language. For example, years ago I stopped using new and recommended using object.create instead. In fact, I managed to get object.create added to the language just so that I could use it. And so I was really surprised to discover that I have stopped using object.create. I mean, it's there for me and I'm not using it. And the reason for that is that I stopped using this. And I stopped using this because I did an experiment called AdSafe. In 2007, several companies were involved in trying to figure out how to secure JavaScript so we could have safe third-party interactions in web browsers. There was FBJS at Facebook, there was Web Sandbox at Microsoft, there was Caja at Google, and my own AdSafe project, and several others. And the difficult problem we all had was what to do with this. Because if you have a method, this gets bound to the object of interest, which is good. But if you call that same method as a function, this gets bound to the global object, which violates all of our security. So how do you deal with that? What the others did was they came up with translators. So they would read a JavaScript file and they would write a JavaScript file, adding lots of indirection and runtime checking in order to make sure that this is always bound correctly and other things. My ad safe took a completely different approach. I just said, this is too difficult to figure out, so we're going to make it illegal. So we'll reject any program that has this in it. And as a result, everything ran faster, but the percentage of existing programs that worked correctly with AdSafe was 0, because everybody's using this. So as an experiment, I started writing in the dialect of JavaScript that didn't have this, just to show that it's possible. And I was really surprised to learn that it was better, that the programs I was writing were now smaller and better. And it's like, I thought it would be not too much more difficult, but it was actually an improvement. So I'm not using this anymore. Also, not using this makes the language a lot easier to talk about, because this is a pronoun. And when you say, this stinks, it's hard to know which this are you talking about. I stopped using null. JavaScript has null and undefined. It has too many bottom values. A language should have no more than one. And I decided to not use null because the language itself doesn't use null. The language uses undefined. And also null has the problem of type of, which gives you incorrect results. So I don't use this or null. And I think the falsy values were a mistake as well. The falsy values were intended to allow a style of conditions similar to what you do in C. Java did not make that mistake. Java requires that all conditions be Booleans, and I think that was correct. I don't use for anymore. ES5 introduced array methods such as for each, which will automatically go through each element of an array, so I don't need for. And I don't need for in because ES5 also introduced object.keys, which will give you an array of strings, which are the keys of an object. And so I don't need for in to get those anymore. ES6 will provide proper tail calls, and at that point, I'm going to stop doing loops entirely. So here are two versions of the repeat function. The first one is written using a while loop. The second one is using tail recursion. And in ES6, both of these will run at the same speed. And so from now on, I'm going with recursion. I like functions. So I've been thinking a lot about the next language. What will be the language that replaces JavaScript? And I have to believe that there's going to be a next language, because if it turns out that JavaScript is the last language, that would be really sad. So there's got to be something else that follows it. And there have been a number of proposals for languages which claim to be the next language, but I don't think any of them are it. But one thing I'm confident of is that when the next language does appear, we will all reject it immediately. So here's why I think that. It's because programmers are as emotional and irrational as normal people. And here's my evidence for that. It took a generation to agree that high-level languages were a good idea. When Fortran was invented, most professional programmers refused to use it. They insisted that they had to continue to write machine language, that they gave up too much control to the programming language, and they couldn't do that. They would have benefited hugely. It's so much easier to write in a higher level language than in machine language. It took a generation to agree that GoTo was a good idea. Dijkstra published his letter in 1968, and we argued about it bitterly for 2 decades. And the arguments were all, that I need every tool of the language to do my work. I have a right to use GoTo. GoTo is how I express myself. We have a tradition. My grandfather used GoTo. I'm going to use GoTo. Turned out all those arguments were wrong. It took a generation to agree that objects were a good idea. Xerox PARC spent a decade refining Smalltalk 80. It's maybe the best designed programming language in history. Our industry had to choose what the object-oriented programming language of the industry was going to be, and we chose C++ instead. And that decision was made by people who did not understand what object-oriented programming was. And so they preferred C++ because you didn't need to know anything about object-oriented programming in order to use it. And there are things that C++ got wrong about objects which have been copied into virtually every language since then. So it's unlikely that we're ever going to get that right. And then it took 2 generations to agree that lambdas or functions were a good idea. That was an idea that was discovered in Scheme, and it took 40 years for that to finally get to the mainstream. And the reason that it's finally getting to the mainstream now is because we're doing a lot of distributed programming and a lot of asynchronous programming. And it turns out functions give us a lot of leverage in solving the problems unique to those domains. So the reason each of these takes at least a generation is because we don't change minds. We never finally convince people that, you need to get rid of the go-to or whatever. We just have to wait for a generation to retire or die before we can get critical mass on the good idea. We look around and say, are they gone? Can we get rid of the go-to now? Great. So we got rid of the go-to. Nobody misses it. It's hard to remember why it was so controversial. And I expect the next language is going to be like that. So I would like to classify languages into 2 major types: systems languages and application languages. System language is what you would write a kernel or a memory manager or a device driver, something that wants to be really low level and fundamental, and everything else should be written in application languages. I think one of the biggest mistakes in Java was it couldn't decide which side of this line it wanted to be on. And so that caused some bad consequences, like threads are required in application programs, which I think was a tragic mistake. So I would like to see better languages show up in both categories. Our best systems language still seems to be C, and that language is really old now. We seem to have lost the ability to innovate in systems languages. I don't know why that is. But I'm mostly focused now on the next application language. What's the language that's going to replace JavaScript? You can take application languages, and they're all object-oriented now, and divide them into 2 classes. There's the classical school and the prototypal school. Almost all of the languages are classical. JavaScript is one of the few prototypal languages. And I used to be a big advocate of the prototypal inheritance. And the reason for that is that there are all these inherent problems in the classical model. When you're designing a system in the classical model, you have to first do a classification in which you look at each of the objects in your system and determine what properties does it need to have, what members, what methods, and then you do the really hard work of taxonomy, where you look at how are all of the objects related to each other, what is going to implement what, what's going to inherit from what. That turns out to be really complicated in a complex system, and it's very hard to do correctly, because at the time you have to do that, which is usually the beginning of the project, you have the least understanding of how it's all going to work. So inevitably, you get it wrong. And that means you now have a broken object model, and as you start building new classes on top of it, that brokenness finds itself weeping into the other classes, and it gets harder and harder, and you're finding that the classes don't compose properly, and you're wishing you had multiple inheritance, and it's get all this friction, and eventually it gets so bad that you have to refactor, which means you have to tear it all apart and try to put it back together correctly, which is really hard, and sometimes it doesn't go back together. And it turns out this is not an inevitable part of programming. This is just classes. If you get rid of classes, all of that disappears. You don't have to do any of that. I try to tell that to people who are trained in Java, and they go, wow, that's amazing. Except you still have to do all that. And I go, no, you don't. You don't do any of that. I go, wow, that's great. But you still have to do all of that. No, it turns out you don't. So I was a big advocate of prototypal inheritance. But it turns out the best feature of prototypal inheritance is memory conservation. That you can have a single object which is a prototype for several others, so the material that's in the first object does not need to be replicated, and that can save a lot of memory. So if you're using object.create instead of object.copy, the main benefit is we're saving memory. And I think that made a lot of sense in 1995. But it doesn't anymore. I mean, Moore's law has continued to crank on memory capacity. You now have gigabytes in your pocket. We cannot imagine how big a gigabyte of memory is. It's just incomprehensible to us. And you've got several of those in your pocket. It's just amazing. So obsessing about how much memory is being allocated per object doesn't make sense unless you're making hundreds of thousands of instances. And I suspect that if you are, you're probably using the wrong language. So memory conservation is no longer a benefit. It comes with some cost. For example, there's the confusion between own and inherited properties, and that confusion can lead to bugs. You also get retroactive heredity, in that you can change what an object inherits after it's been constructed. There's no good reason to allow that, but it's just part of the prototypal model. But it comes with badness. One of badness is that it's performance inhibiting. Modern JavaScript engines get better performance by making assumptions about the shape of objects, but they have to be pessimistic about prototype chains because a prototype can change at any time. So it's actually inhibiting the speed of the language. So I'm now thinking that prototypal inheritance is an idea that we don't need anymore, that I think the real benefit in JavaScript is class-free programming, that the JavaScript's gift to humanity is class-free programming. So let me describe how that works. This is an example of block scope. Will be something that all languages do this. JavaScript will do it next year. We've got two blocks. The inner block can see the variables of the outer block. And we've always been able to have nested functions, and the inner function can see the variables of the outer function. And we can express that as sets. So here we've got the set of variables available to the outer function, and this is the set of variables available to the inner function. And we can say that the inner functions set encloses the outer function set. And so this idea is called closure. And the difficulty in getting this idea to market was figuring out what to do if the inner function survives the invocation of the outer function. And it turns out this is trivial to do if you have a good garbage collector and if you're not using a stack. So you just do all your activation records in the heap and everything works. So having closure in the language, which I think is the best idea in the history of programming, it was something that was invented in Scheme. The first language to bring this idea to the mainstream was JavaScript, and now virtually all languages are able to do this. So this is how I recommend making objects in JavaScript. This is how I'm going to be doing it next year. I've got a constructor. I'm going to pass in a specification object, which will just probably be an object literal or maybe a JSON payload, which will describe what kind of object I want to make. I'm going to use the new deconstruction syntax to create my member variables. These are all the private variables of my object, and each will receive a value from the specification object. I can call another constructor, and it will return an object, and then I can copy specific methods from that object into local variables. So this solves one of the problems of classical inheritance, where I don't have to inherit everything that that class can do and everything that it ever inherited and so on. I only have to inherit the parts that provide value to me. And because I'm being selective, I can call as many of these as I want, so I can get multiple inheritance. Then I create my methods, and my methods will close over all the members, all of the other methods, over my methods, and over the specification object. I don't use this in writing the methods. Then I have the outgoing object. We have some new syntax in JavaScript where I can create an object literal, and instead of saying method colon method, I can simply say method. And I'm going to freeze the object so that the object is now completely immutable. So that means it cannot be tampered with, it cannot be corrupted. It can now provide very strong, safe interfaces, which I think application integrity requires. So I think object-oriented programming started with the idea of, we'll take a Pascal record and we'll add some functions to it which will allow you to act on the properties of that record. And I think that was an important evolutionary step, but it should not have been the last step. So where I'm going now is I've got two completely different kinds of objects. I've got data objects, which just contain data, they're mutable, and generally they're hidden behind methods. And then I've got the real objects, which are just a collection of functions, and the object itself is frozen. So I need to confess. I made a bug in 2001, and I got a bug report on it last year. So this is the code that went wrong. I wrote a JSON parser in Java, and this variable index counted the number of characters we were into a string or a stream, so that if there were a syntax error, I could report the number of the character where the error occurred. And last year I got an error report. It turns out someone had thrown a JSON text at my code that was several gigabytes in size. When I designed JSON, I didn't anticipate there ever be messages larger than a couple of K. And I thought, well, this variable can go up to a couple gigabytes, so that's completely safe. I mean, a couple gigabytes at the time I wrote the program was a fairly large disk drive. But these guys had a JSON text that was several gigabytes in size, and they had a syntax error past 2 gigabytes. So this returned a negative number, which was completely wrong. So the source of the error was this, int. I hate int. I think this is a terrible idea. It's one of the bad ideas in programming. And the reason I hate int is because of what happens when you have overflow. So what should happen? If you have a number and it's too big to put in a variable, what should happen? Maybe we should instead put in a nan value to indicate whatever you're looking for, it's not here. Or we could raise an exception. In some cases, you would instead want to put in the largest possible value. That's called saturation, and that can be good in graphics and in signal processing, but you don't want to do that in financial applications. I think the worst possible thing you could do, if what you want to do is maximize the potential for creating bugs, is to throw away the most significant bits and not tell anybody. And that's what we do. We do the worst possible thing. And the way this got started was actually a good idea. In the 50s, computers were made out of vacuum tubes. And tubes are big, and they consume a lot of power, they get hot, and they burn out quickly. So if you can figure out a way to reduce the number of tubes in your ALU, then the machine will be cheaper to produce, cheaper to operate, and will run longer before failure. And some genius, a real genius, figured out that if we do complement arithmetic, you don't have to implement a subtract circuit, we just do a complement, which is cheap, before we do an add, and ignore the overflow. That was brilliant. It was truly a brilliant idea. But we're not using tubes anymore, but we're still doing that. They also come in a large number of sizes, and that's because memory used to be really expensive. It used to be 64K was a supercomputer. The Atari 2600, which was the first computer most people had in their homes, a little game machine, had 128 bytes of RAM in it. Yeah, really tiny. So it really mattered. You know, you didn't want to use more bits to represent a number than you could. But that's not true anymore. You have gigabytes in your pocket. But you look at Java, for example, you've got byte, char, short, int, long, float, and double. And every time you create a variable or a property or a parameter, you have to ask, which one of those? And you have to pick one. And if you pick a good one, then the program works and everything's fine. If you pick the wrong one, the program's going to fail in a really bad way. And maybe not today. Maybe it's not going to fail until years from now, but it's going to fail. And so if you pick the right one, there's no benefit, and if you pick the wrong one, there's an error. And in fact, the value of the bits that you're saving is infinitely smaller than the value of the time you wasted deciding how many bits to save. It's just terrible. Now, JavaScript got it right. JavaScript only has one number type. And so it is impossible to make a mistake by choosing the wrong number type. And that's brilliant. That's a huge advance forward. Unfortunately, it's the wrong type. And the reason it's the wrong type is because of this, that 0.1 plus 0.2 does not equal 0.3. And that's a problem if you're living on a planet that uses the decimal system. This is the most reported bug in JavaScript. And it's not really JavaScript's fault. It's because it's using the binary floating point standard that every other language is also using. So binary floating point is another thing which made a huge amount of sense in the 50s. In the 40s, when the first von Neumann machines started coming online, people first started writing programs in scaled arithmetic, and that turned out to be hard. Then someone figured out, well, if we put the scale factor in a different part of the number, then we can automatically move where the decimal point is, and programming becomes so much easier. So it was great, except the subroutines that did that were really slow, so let's put it into hardware. And again, hardware was made out of tubes, and doing a division by 10, which you need to do in order to scale stuff, is really hard. But if you use binary floating point, then it's just a shift of 1 bit, and that's really cheap. And so binary floating point made a lot of sense in the 50s. Now, the business community couldn't use it because they're adding up money, and money is usually in decimal fractions. So they had their own hardware, binary coded decimal hardware, which was designed for counting money. The scientific community didn't care about that level of precision because all values are approximate generally, so binary worked well for them. So there was this big division. You either had a business machine writing in business languages, or you had a scientific machine writing in scientific languages. Everything we do today is generally in the middle, but in the 50s, that middle didn't exist yet. So, but eventually the business side died and the Fortran branch won, but the idea of doing numbers in Fortran doesn't work for business. So I propose this solution. It's a new number type called DEC64. It's a 64-bit number with a 56-bit coefficient, an 8-bit exponent. It can, and we use a factor of 10 there, which makes it good for doing arithmetic. It does arithmetic the way people do arithmetic, so it's easy to reason about. You don't get the surprises that you get with binary floating point. I've done an implementation of it in x64 assembly language. It can be very fast, and most adds can happen in 5 instructions. In a hardware implementation, most adds could happen in 1 cycle, which would be very, very good. So my recommendation is that going forward, all application languages have only 1 number type, and that it be this one. So it's kind of a difficult thing to try to convince the entire world to make that kind of a change. But it turns out I don't have to convince everybody. I only have to convince one person. And that's the man or the woman who designs the next programming language. If I can convince that person that the correct number of number types is 1, and that it needs to be floating decimal and it needs to be efficient, then it'll happen. Now, I have some experience in convincing everybody in the world to do the right thing. For example, there's the JSON data interchange format, the world's best loved data interchange format. So we can look at how we're doing. This is Google Trends comparing JSON and XML. So this shows that the world has been steadily losing interest in XML since 2005. And JSON is just slowly ramping up. Its growth rate is slow because there is no machine to drive it. There's not a JSON industry. There's no JSON company. There's nobody actually making money on JSON. It's just kind of happening by itself because you figured out it was the right way to do things, and so that's what we're doing. And you can see, it's catching up. So I can't predict when that crossover is going to happen, but Google can. So Google predicts that it looks like in 2005 or 2015, JSON will officially become more interesting than XML. So I never intended that JSON be the last data interchange format. I designed it specifically for dealing with client-server applications, but people have found lots of other good uses for it. And so there should be newer, better formats. And I have some advice to anybody who wants to design one of those. First off, don't change JSON. Don't try to break JSON. Because JSON was designed intentionally with no version number. So there's no way to revise it. There's no way we can say, and this is the new version of JSON. And what that means is that JSON is completely stable. It's never going to change. Everything in the stack potentially changes in the future, but the JSON layer is solid. It's never going to change. And that is really good. I can't imagine any improvement you could make to JSON which is more valuable than that. So if you're going to do something else, make it a new thing. Make it significantly better than JSON. Don't be JSON plus one thing, because that's going to introduce compatibility hazards. So in order to make it worth that compatibility cost, add enough value to justify that cost. And most importantly, give it a better name. I see a lot of proposals for new formats, which is JSON with a new letter in front of it or a new letter behind it, and that's it. Yeah, I mean, the worst part about JSON is the name, I think. I hear from people named Jason all the time saying, why do you do, because I'm, what? You know, they hear people saying their name all the time. And sorry, Jason, I don't know what I was thinking. Also, we're not clear on how to pronounce it. I say Jason, some people say JSON. It turns out the correct pronunciation is JSON. Everyone, JSON. And if you look at the name, so first, JS stands for JavaScript. JavaScript itself is a really confusing name. Some people still think it has something to do with Java, and it doesn't. JavaScript was what inspired JSON, but JSON isn't specifically about JavaScript. It works with all languages, and so putting the name of one specific language in the name is confusing. Some people think that it means that JavaScript is what describes or defines JSON, and it's not. The JSON standard is ECMA 404, not the ECMAScript standard. So just a lot of confusion in the name. Then the word object, that comes from JavaScript's idea of an object, which is just a collection of names and properties. But other languages have a much more brittle version of what object means, and so that's confusing as well. Notation is okay. I can't think of a problem with that, so that's fine. So finally, I want to say a little bit about responsibility. When I'm writing a program, who am I responsible to? Number one, I'm responsible to the people, to the poor bastards who are using my software. I want it to work well for them. I don't want to frustrate them. I don't want to hurt them or have them come to harm because of mistakes that I made. I want to make it as good as I can for them. We have this delusion that our software is making the world better, despite all of the obvious evidence that it's not. But we should at least make it better for the people who are using our software at the moment that they're using our software. We should at least be able to do that. I've seen some teams which have contempt for their users. They hate the people who are using their stuff. Oh, they're so stupid, they don't know how to use it, they're always giving us bug reports, they don't appreciate our brilliance. That is really toxic. That's a terrible, terrible way to think. I think everything we should do should be in service to humanity, and specifically the humans who are using our stuff. My second responsibility is to the team. I want to be writing the best code that I can because other people on my team are going to have to take my code and make it better. So I don't want to be putting traps into the code, things which are going to screw them up, make it harder for them to do their work. And I'm also concerned about people who we haven't hired yet, people who I haven't met but who will someday need to be able to use my stuff. I need to think about them. So software has become this really complicated thing. It requires larger and larger teams in order to create it and maintain it. It's similar to the kind of work that you would do in writing an encyclopedia or any other collaborative work. And in such a thing, you want it to look like it's written by a single author, even though there might be hundreds of authors involved in it. And so I want that in our code base. I want it to look like our code base was written by one person. And I want it to look like it was written by the smartest, most professional programmer who has ever lived. I want everybody on the team to be writing up at that level. I don't want anybody dumbing it down because they think they need to express themselves. We express ourselves by the clarity and the correctness of what we do, not by being eccentric. Then finally, number 3, management. They're paying for it, so whenever they say something that makes sense, we'll do that too. And some managers will go, whoa, 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 wait a minute. We should be number 1 here. But I think, no, I think I got this right. I think they're number 3. And I think a good manager would agree with me. One thing that tends to happen in businesses is the people in the business tend to mostly get concerned with the business itself and the internal stuff, the competition for internal resources and so on, and that the whole thing becomes kind of inward focused. And one of a CEO's jobs is to try to turn that around and get everybody to remember what's going on the outside, that competition is going on out there, and that our customers are out there, so be aware of the customer. Everybody who's doing customer service, be the customer, all of that. Be focused on the customer. Number 1 is the customer. So this is completely compatible with the best business practices. A big problem that companies have is that their code bases become crappy. You get the legacy stuff and the code bases become bloated and crufty and brittle, and the badness in the code base makes it impossible to be competitive. That you want to be able to take new ideas to market quickly, but you can't because it takes so long to get the software changed. If we were designing software for the team, then the code base becomes a positive asset of the company, not a liability, and we can compete more effectively. Then number 3, management. Now, if you're writing software for yourself, if you're doing hobbies or if you're a lone wolf, I think it still applies. Number 1 is still whoever's going to be using your stuff. So unless you're writing something that's strictly only for your own use, I think you still need to be first concerned about the people who are going to be using it. You are the team, so you're writing for the team. Except if you ever expect that you're going to open source it, if there's that potential, then potentially your team includes every programmer in the world. So make it good for them. And then finally, now your management. So now you're number 3. So I'd like to leave you now with just one piece of advice, and I think this is the best piece of advice that I can give you. I'm really serious about this. Please, don't make bugs. Thank you, and good night.